Hi. What I thought I'd do is talk you through how to do calculations from worksheet 4. So you should watch this if doing limiting reactants in terms of heat that is being given off or absorbed is confusing you. I'm going to be working number 4, and I'm also going to work number 6. On worksheet 4, number 4, they give you the equation that 4 moles of aluminum plus 3 moles of oxygen will yield 2 moles of aluminum oxide. And they also give you that the heat of the reaction, the enthalpy of the reaction is delta H, is negative 3,352 kilojoules. This means that if I were going to write this in the chemical equation, it would go on the product side. The negative sign means that it's giving off heat. Okay. They also gave me that I had 85 grams of aluminum, and they gave me that I had 95 grams of oxygen. So I'm going to need to use the molar mass, MM means molar mass, of aluminum in order to convert the grams of aluminum into moles of aluminum. So I looked on my periodic table, and I found the molar mass of aluminum is 26.982 grams. That's how much 1 mole of aluminum weighs. And then for oxygen, the molar mass of oxygen is actually 15.999, and the molecule of oxygen has 2 of them. So I multiply 2 times 15.999, which gives me the molar mass of oxygen is 31.998 grams. And they're asking me how much energy is given off, how much energy would be made starting with these amounts. So in order to use the chemical reaction in the stoichiometry, you can't do anything without converting everything to moles, because this is the mole ratio. And it says that if I had 4 moles of aluminum, that's how much kilojoules I would produce. And if I had 3 moles of oxygen, assuming I had plenty of aluminum, then I would produce 3,352 kilojoules. So you can create an equivalence to convert one into the other, but only if your information is actually in moles. So the first thing I'm going to do is calculate the molar mass of aluminum, because I got to know how many moles of aluminum I have. Now you could do this all in one long line of these grids that I taught you how to do, but I was thinking that maybe this would be easier to follow. So 85 grams divided by the molar mass of aluminum would give you 3.1502 moles of aluminum. And I do the same thing for oxygen. I take my 95 grams and I divide it by the molar mass of oxygen so that I can cancel out grams, and I'm left in moles of oxygen. So now I'm in moles, and now I can use the mole ratios of my reaction. So right here, just to reiterate, you must convert grams to moles to use the chemical reaction mole ratios. If you're going to try to be converting this into an amount of energy given off, you need to be using moles to do it. So based on this chemical reaction right here, I said, okay, I started with 3.1502 moles of aluminum that I got from over here. And then I said the molar mass of this chemical reaction is 3,352 kilojoules. That means that if I had 4 moles of aluminum, like the reaction told me I would need, then that's how many kilojoules would be given off. But I don't have 4 moles, so I'm going to be able to cancel out moles and put it into kilojoules if I divide it by the number of moles of aluminum that I got from the chemical reaction, the chemical equation. And it says that once you plug this into your calculator, you would get 2,639.87 kilojoules. And the negative is really important. It means it's exothermic. So ignore the limiting reactant for a second, because I wanted to show you the other one. you can't figure out that this is limiting reactant without doing both of these, because what you have to do is pick the one that produces the least amount of energy. That's the one that is actually how much you're going to make. So you're actually going to make the amount that is determined by your limiting reactant. And aluminum in this case, because it produces the least amount of product, the aluminum is what is limiting your reaction. So this is the realistic amount that you would give off. This one would be, the oxygen would be the excess reactant. So if I was going to write it out, it would mean that 2,640 kilojoules of energy would be given off. The negative sign means that it would be given off, okay? Will be produced, okay? So that's number 4. Now let's do number 6. Basically doing the same thing, except this one didn't give me a delta H. Instead, it wrote the heat of the reaction as part of the equation. This means that my delta H is actually going to be plus 72.80 kilojoules. Because it's one of the reactants, it means it's endothermic, and the heat of the reaction is a plus sign. Okay. So once again, I have to calculate molar mass. I'm going to need it to convert the grams that they gave me. They gave me 38.2 grams of bromine, and I need to turn that into moles using the molar mass. And I did the same thing for the hydrogen. They gave me 12.4 grams of hydrogen, but I can't do anything with that. I need to turn it into moles using the molar mass. So here's this is how many grams 1 mole of hydrogen weighs. So now I can convert grams into moles. I can actually cancel out my units. So I started with 38 grams of bromine. I have grams on the bottom and grams on the top. So now all I'm left with is moles of bromine. So I know that if I divide 38.2 by 159.808, that would give me moles of bromine. Okay, and I have a whole lot of extra figures that I will get rid of in the final answer. Okay. All right, I do the same thing for hydrogen. I use the molar mass of hydrogen so that I can cancel out grams. And now my units are moles of hydrogen. From this point, I'm going to use this chemical equation to do stoichiometry. So once again, ignore the limiting reactant. I guess spoiler alert, because I'm going to have to do this twice. But I start with moles of bromine, and I'm going to use this mole ratio that for every mole of bromine, this is how many kilojoules I'm going to need. So 1 mole of bromide will require 72.8 kilojoules of energy in order to make the chemical reaction progress to products. So converting, I know I did it right because I can cancel out the moles and I'm left in the kilojoules, which is what they asked for. So this is how many kilojoules would be produced from this many moles of bromine. I have to do this for both of the reactants because until I do this for both of the reactants, I don't know which one produces the least amount. But obviously, when I cancel out moles for hydrogen and I plug that into my calculator, 447.8 kilojoules is way more than 17.4 kilojoules. When you're trying to determine how much will actually be made, it's going to be limited by the limiting reactant, which is the reactant whose moles allow you to make the least amount of product. And so therefore, the answer to this is that 17.40 kilojoules will be absorbed, and the sign on this should be a positive because that means that it's endothermic. And that's how you do the problems from worksheet number 4.